this section, we are going to go over what is called compound optimizations. Now, on the screen is under a section in the tune portion called Quantitative Optimizations. The purpose of us performing these compound optimizations is so we can get the optimized parameters for each specific drug that we would like to use on this system. So what this system is going to do is we're going to use the syringe pump that we've used before. We're going to infuse a diluted solution of whatever analyte you'd like to use. In this case, we're going to use some cocaine standard that we made up. It's about 5 milligrams per liter concentration. And we're going to infuse it into the system and run an automated program where it's going to vary, it's going to ramp some parameters, and ultimately it's going to spit us out a report which lets us know which parameters have been optimized and what those results are. There's a couple of different ways that you can do this. You can set your syringe up. Let me go ahead and do that. You can set your syringe up just to infuse the compound of interest, which is what we're going to do. You can also have the system set up to infuse compound and mobile phase at the same time. We talked about that when we went over hardware configuration and the system setup. If we change this little insert here, we can actually have infusion standard and mobile phase flowing into the system at the same time. The software will also perform a function called flow injection analysis, where you can have it optimize your sample and build a method for you around those parameters. But what we're going to do is we're going to do the basic setup, which is infusing a compound into the instrument with the automated program. So the first thing we need to do is we're going to change our project. Which project would you like to put this in, Bill? Oh, that's right, we do. As Bill said before, we don't want to run these in the API instrument folder. You can put them in any other project you want to. The next thing we need to do is change our hardware configuration to accurately reflect the system setup that we're going to use. Since we're going to be infusing with the mass spec, we need to activate the mass spec with the syringe pump profile. So we will activate that. Okay. Then, I believe, Bill, correct me if I'm wrong, but we need to set this up under the manual tune section first so that we can start the syringe pump?
Yes.
Is that true? Okay.
To see that you get a total line count that stays the same
Okay.
throughout the run.
Okay. So, let's see what we got here. Now we can just do that from the general manual tune screen. Is that correct?
Correct.
Okay. Do we need to change the scan type?
You can use Q1.
Okay. But we got to put in a start and a stop mass unit. So, what shall we use? For cocaine, we're going to use, it's about 304, so we should use what, maybe 250 to 300?
We've got to go past 304, so we're going to go to
Oh, that's right.
325,
What am I thinking?
350.
325. Okay, so how about maybe half a second? Let's try this. We'll set our flow rate for our syringe pump. It's not going very fast, just 10 microliters per minute. Let's go back to our mass spec method. Check our parameters. Okay. It's going to give us a 5-minute duration period so we can have a nice window to check and make sure we're getting a good signal. I don't think we need to change anything else.
I think you're set to go.
Okay. I think so too. Okay, well let's start this and see how it goes. And again, it takes the software just a second to get acclimated to what you're asking it to do. Okay, so we can see our signal in this pane, very similar to what we did with the tune. And this is going to show us the actual data.
There it is.
I saw a 304. The signal's not very level yet. Give it a minute or two. Because similar to when we're running in the tune check, we want to make sure we have a nice stable signal before we start collecting some data. Okay. I'm not sure. Well, we'll give it a try and see how it works. It doesn't look very good.
Air bubble.
And that doesn't
There
look
we
very
go.
good either. Okay.
What we probably should do is ramp the syringe speed up just to make sure that we're getting a good solution that we put in there through there.
Yeah, you're probably right, Bill. Okay. You change that. We'll set it a little higher just to get some solution going. Let's see how that works. See, now we have a nice one. Big 304. Okay. Reset it back to 10. See if maybe we've gotten all the kinks worked out of the signal. That looks pretty good. Okay, so we will stop collecting data from this panel, and we will go ahead and double click on our quantitative optimization function in the tune section. No, we do not want to save the acquisition record. Now, there's going to be a series of panes in this function where you can fill out some specific information that you need to use for whatever infusion data you'd like to collect. So in this pane, if you wanted to do the flow injection analysis, this is where you would select that. For us, we're not going to do that today. Okay. Now, correct me if I'm wrong, Bill, but I think this is the section where we can specify how many ions it's going to show us. Is that correct?
I've never
you
changed
remember?
anything there.
I think you have.
Very good.
Okay, so in this section, you can tell it how many peaks you would like it to give you a result for. In this case, it's set up to give you the three most intense peaks when it performs its infusion experiment. You can also tell it a minimum mass for the product ion. We use this section to exclude losses of water when we're actually performing the collision-induced dissociations. So 55 would be okay. So we'll just go ahead and use these parameters that are in there and go to the next pane. We're going to specify which compound we're using, which is cocaine, and its molecular weight, which is 303, and the number of charges. And then when we're finished, it's going to perform its functions for us. Okay? Now, sometimes what can occur when you're performing this quantitative optimization is exactly what's happened. It tells you that it's aborted the optimization because the signal is too concentrated. 5 milligrams per liter is a good starting point. Sometimes, depending on the compound, you may have to dilute it and re-inject it. So that's what we'll have to do in this case. Okay, so let's stop our syringe pump and go ahead and make a dilution of the cocaine, which I don't think we have. Do you have one for me?
I do not. Do you have a little needle over there?
Oh, I do. Right here it is. Which one do you want? That one or this one? There you go. Please hold.
I'm just going to make a real rough dilution. I'm going to squirt out about 3/4 of this. And
Okay.
hopefully it won't be too dilute.
It works without putting a syringe needle on it too.
It does work without the syringe needle in it.
I never put one on. I never put one on.
That's because you're a rebel, Bill.
It's only just squirting through here.
Mix it.
Now it'll work.
I don't know. We'll make sure we mix it before we even shake it.
This won't be too high.
He's going to put some through
How
it
do they
too.
mix it?
In the syringe. He turned it up. Would you like to double check it before we do it?
No.
Okay.
Thank you.
Welcome.
Okay, now that we've made a dilution, now the dilution itself doesn't have to be very exact. You can make the dilution inside the syringe. You can just squirt out some of your analyte and draw up some water or mobile phase, whatever your solvent is, and actually dilute it inside the syringe. Okay, let's try this again. We're going to up our mobile or our syringe flow rate a little bit since we've changed it. We're going to start. Oops. Oh, that's right. Look, it's giving me all kinds of errors because I forgot to fill out my table. Oops. Which is exactly what it will do. If you don't have your table filled out and go to collect some data, it will tell you that that is impossible. Okay. Now let's start this up again, see what we get. Now I've left it in the syringe pump method screen just so that once we realize we have a nice steady injection, we can change the flow rate back down to 10. Give it a little bit. I don't remember what it was before. Do you remember what the intensity was before?
No, I don't.
Okay. We'll go ahead and change it to 10 microliters per minute. We've got good cocaine signal intensity over here. The signal looks pretty stable right there, so let's go ahead and give it a try. So we'll stop this function here, and we'll go back to the quantitative optimization screen.
One other note there.
Okay?
The total counts for the signal there can give you a clue of whether or not you have to do another dilution. I believe it has to be in the 10 to the 6 range. Many
is that
times.
here or is that over here?
I'm not sure. But if you're doing 150 samples, this would be a good point to learn what the signal needs to be before you get into the compound optimization function.
You're exactly right. So you want us to go ahead and see what we got?
Sure.
No, I do not want to save the method. Dilution. This criteria is not going to change. It's going to be whatever it was you left it the last time, so you don't have to go back in every single time you perform this function and do it again. And this information is going to stay the same too. So we're finished. It's going to start up again. And if it tells us it's too concentrated, then we go through all this again. The intensity on that previous pane was about 9 to the 6, so it seemed to like that because we progressed. Now it's going to scan through some various parameters to determine which one is optimal for this analyte and each individual transition that it determines in a minute. Okay. One of the functions that the quantitative optimization performs for you is it demonstrates the fragmentation pattern of the analyte during this process. So you get a nice picture of what sort of fragmentation pattern you're getting through your particular compound. In this case, it's cocaine. And so you can see we're getting some good fragmentation even on the low end. It's going to do 26 scans, I think, and add them all together. Now, the data that it collects in these various panes while it's going through the quantitative optimization, it stores in various folders on the hard drive. So all of this data is accessible in other places, not just here. On this pane, you can see it's got various transitions that it's performing the optimization on, which is why we've got 3 different colored transitions. It's almost done. I never realized it took this long.
Yes.
Okay. This is the last pane that it's going to show you, and it shows the peak shape for each individual transition that is selected, I think. Is that correct?
Yes.
Okay.
It's collecting 10 scans.
Mm-hmm. It looks like it's finished. So, in general, the data that we collect and we keep for our own resources includes this pane, so you can see which fragments it has selected as the best ones, and you can see the intensities. We also want to keep this text pane, which is going to show you the individual transition data that you're going to use to build your method, because each transition that you want to include has its own specific set of criteria that have to be put in there, and that's where you get this data. We can go over this data when we discuss actual method development. Okay. We also normally will keep a copy of the pane of the fragmentation pattern, the total fragmentation pattern for each analyte, just so that we have it on record. Can you think of anything else? Okay. So we're going to go back into the manual tuning pane so that we can turn off our syringe pump. But this process, the optimization of parameters for cocaine, is finished. So now if you wanted to develop a method for cocaine, you have all your analyte parameters to use.